Okay, so today we are going to be doing lesson 12. This one we're looking at the graph of the equation y equals f of x. So last time we talked about graphing and using code to create a graph of f of x. So last time we actually graphed the coordinate points x, f of x. This time now we're going to start working towards the x and y. When we did it last time, we almost assumed that f of x equaled y. This time we're going to be working towards actually how those two are the same, what it means, things of that. So this first example, it says, in the previous lesson, we studied a simple type of instruction that computers perform called a for next loop. So if you recall, this is what we had last time, this for next loop. So another simple type of instruction is an if-then statement. So if-then statement, this is a pretty common one. This is something that is used often. I remember there was a Swift Playground that some of you guys can access. The high schoolers, you guys can access this one. That one does a lot of if-then statements. So what we're going to be looking at is an if-then statement, and it says below is an example code of a program that tests for and prints true when x plus 2 equals 4, otherwise it prints false. So this is, some of these are very similar to last time, some are a little different. So declare x is an integer. This is going to be our possible domain. Okay, so that is our possible domain, and if you recall, integers, those are going to be, it's going to be your positive and negative whole numbers. And so this will also include 0. So including 0. Okay, so then the next line, it says for all x from 1 to 4. So we're going to be running this code from 1 to 4. So all the possible integer values between 1 and 4 is going to be 1, 2, 3, and 4. So this is where it's a little different. So the if statement, it says if x plus 2 equals 4, then we will print true. Else just means anything else. If it's not true, if they don't equal, then we print false. And so this is the end of our if statement, and then we'll run the next x. So this just tells us, okay, go back to the next one until we run out of integers to go through. So for the first one, we'll just write it out. 1 plus 2 equals 4. And then is that true or false? Well, 1 plus 2 is going to equal 3. That does not equal 4. So we have false. And that's what was printed right down here. So this is false. So then we go to the next one, and it is 2 plus 2 equals 4. 4 equals 4. That's true. And they wrote true next to here. And so we just keep on going. The next one would be 5 does not equal 4, and 6 does not equal 4. Again, just substituting in. So we're going to get false and false. So everything they wrote there. So it says right here, notice that the if-then statement in the code above is really just testing whether each number in the loop is in the solution set. So all it's doing is it's scanning through possible x values that'll give us, x plus 2 equals 4. This is what we're going to start doing with the y. So if you'll notice the x plus 2, it's almost like saying y, but we just chose a value for y. So we're going to end up working with this, and it tests a bunch of different numbers to see what value will work. So that is the first one. Okay, example 2. So it says, perform the instructions in the following programming code as if you were a computer and your paper were the computer screen. So again, we have declare x as integers. It means we're only working with whole numbers, positive, negative, and 0. So initialize G as a set notation. This is the same as last time. It just means we're going to write our answers in these lovely curly brackets that I know all of you absolutely love to draw. Okay, so then the next one for all x from 0 to 4. So we'll just be testing 0 to 4, and then we'll go from here. So for all 0 to 4, we're going to plug them into this right here. So this is going to be our equation. So if that is true, then we're going to append, or we're going to add it to G. So add to set G. If it's not, then we're not going to append it. We're not writing true or false in this one. We're just going to put it in or not. And then we end the if statement, we go to the next x. So it pushes us all the way back up to the top. So if we were doing this, the first one would be, it would be 0 squared minus 4 times 0 plus 5 equals 2. So 0 squared is going to be 0 minus 4 times 0 is 0, and then plus 5. That does not equal 2. It would be 5 equals 2. So that won't work. So then the next number, we plug in 1. So 1 squared minus 4 times 1 plus 5. Does that equal 2? So 1 squared is going to be 1 minus 4 times 1, 4 plus 5. So what this is going to end up being is 2 equals 2. So that would work. So this x value we need to put into our set notation. So we'd have a 1 there. As you can see, the next answer that will work is 3, so we could plug in 2 and test it. If you want more experience plugging these in, then I would suggest doing it. Just see what number you get. So then the next one that would work is 3, so you do 3 squared minus 4 times 3 plus 5. Does that equal 2? According to this it is, but we should just check and make sure. So 3 squared is going to be 9 minus, and then we have 4 times 3. That's a times. So that's going to be 12 plus 5 more equals 2. So we have 9 minus 12, that's negative 3, plus 5, we're going to get 2. 2 equals 2. So 3 does work, and that is the end. So this one, what it wanted us to do was it just wanted us to find which ones worked and then put them in there. The one from example 1, we just were looking for true-false values. So other than reading the code, this is something that we've worked with quite a bit. So this next part, it's saying compare the for next to the if-then code above for builder notation. So in builder notation, or set builder notation for this one, it's a little different. This time now we're going to put, this is our, I like to call it possible domain. It's kind of the restraints or what we're working with. So we have our x as integers, and so this line actually gets read as such as. So we're going to say x is integers such as, and then this is going to be our domain. So we're going to be looking at numbers that are from 0 is less than or equal to x, which is less than or equal to 4. And then this is going to be our function that we're looking at. So this is our function slash the expression. So this is what we will be plugging into. So whenever we find an x, whatever one we're going to use, so the first one would be 0, we plug it in, see if it works. And so you could use the set builder notation just to check. Here's kind of how you would do it. You just take 0 as your first one, so you do 0 squared minus 4 times 0. And then you're going to add 5, that equals 2. So this is the exact same as what we did up above, so we know that 2 equals 2. So set builder, it's just a nice shorthand for everything that's up here. So that's pretty much it for those two. Okay, this is where you're going to get to actually practice this a little. So this is the exploratory challenge, and so this time it says next we write code that generates a graph of two variable equations. So what we were looking at before would have been one variable equation. Our answer was already chosen, so we didn't have to necessarily find what y values would work for graphing purposes. So next we write code that generates a graph of a two variable equation, y equals x, and it's x in parentheses times x minus 2, close parentheses, open parentheses, x plus 2, close parentheses. So this time we're going to run through these values for each x. So we're going to do -2, -1, 0, 1, 2. And then we're going to look at the y values of -3, 0, and 3. So this is going to be our domain, just so that you get a little bit more experience with it, and this is your range. So it put them into nice coordinate points. Here's what we're testing. Here's what we're looking at. So we're looking at -2, -3. Then we'll look at -2, 0, and -2, 3. We are going to plug in and see if these x's give us -3, 0, or 3. That's what we're looking at testing here. So to see if this works, we are going to run it through this code, and then we're going to graph it. So when it says Cartesian, that's just our xy plane. That's all we're talking about there. So we can instruct a computer to find these points. So this one here, it says declare x and y integers. So all we're doing is just, these are going to be whole numbers. We've done this before. And then we're going to put this in a set notation. So for this one, it's kind of an interesting thing. So there are two loops in here. So for an x loop. So this first one says that we're going to test each x. So there's this neat chart down here. It's really going to help us kind of make sense of this. So for all y's in -3, 0, and 3, we're going to test -2. When we're done, then we'll go test -1 with all these values, -3, 0, 3. And then we'll go to 0, -3, 0, 3. And we're just going to keep on testing and see if we get those to be true or not. So if y equals, and there's our equation, then we're going to add it to our g. So that'll end up coming down here. Or else we're just not going to append it. So we're not going to add it on there. So it ends the if statement, and then we'll go back to the next y. And so we'll keep on running all the y's until we're done with the y's. So we've done -3, 0, and 3. And then we'll come and we'll run the next x. And we'll go through this first. So right here it says this section is going to test if x or y is a solution, and then it loops through each one. So that's what it's saying this overall part does. So the first part here is already done for us. So it went through and it plugged in -2, and it saw if the answer was -3, 0, or 3. So I think a quick way to do this is we can just plug in and say y equals, and so then for this one we're looking at -2. So for every time we see x, we should plug in -2. So -2 times -2 minus 2, and then -2 plus 2. Okay, so we are going to see really quickly something's going to happen. So we have -2. Inside this parentheses is going to be -4, and inside this parentheses is going to be 0. Anything times 0 is 0, so this y equals 0. So that's why they went through. No, it's not -3. Yes, it's 0. No, it's not 3. So that's kind of what it's wanting us to check and see. So I'm going to give you a little bit of time. You're going to go through and you're going to see, okay, -1, which one works, if any, 0, 1, and 2. So you're going to go through that on your own, and then we'll come back to that.